Good day. In this video, we will learn how to perform unsupervised machine learning using WEKA. But before that, what is unsupervised machine learning? It is a type of machine learning that looks for previously undetected patterns in a dataset with no pre-existing labels and with a minimum of human supervision. Common algorithms in WEKA include the following. We have the k-means clustering, we have the EM or the expectation maximization clustering, and the a priori algorithm for association rule learning. So let's proceed with our WEKA. Again, open your WEKA, open your Explorer interface, then open your dataset in the ARFF file format. Again, in my case, I place it in WEKA, diabetes binary. Again, we need to pre-process our data. First, let's designate diabetes binary as our dependent or our class, since our class income is the default binary class, since it is the number or the last attribute in the list of attributes or in your dataset. So therefore, when cleaning your dataset, your dependent variable or your target variable should be at the last column so that when you load it using WEKA, it will automatically be designated as your class. But since our diabetes binary is at the first column of our file, let's uh, let's designate it as our class by clicking the edit button here, then hovering your mouse again here in the diabetes binary and right clicking it and attribute as a class, then click OK. So the diabetes binary became the last column here, then click OK. And as you can see, your class is now diabetes binary. Then we need also to reprocess our data to normalize it. Again, like for example, the BMI has different minimum and maximum values. So please watch our video in supervised learning for more details. Okay, so let's normalize it. Again, let's click the choose here in the filter, then the filter, unsupervised, attribute. Then click the normalize here. Then once selected, it will appear here. Then click apply. After applying, you can see our BMI has already a minimum value of 0 and 1. So it is ready for analyzation. Since this is unsupervised machine learning, we will utilize the cluster. Again, like your supervised machine learning in the classify, first you choose your algorithm here. So we have in WEKA, we have 1, 2, 3, 4, 5, 6, 7, 8 different clustering algorithms to choose. Then again here in the cluster mode, we use the training set. Again, supplied test set if you have the different tests data set. Or your percentage split, again 80% for your training data set and 20% for your testing data set. Or what classes to clusters, or your class binary, since we are clustering where who will be with diabetes or not, although it's unlabeled. Okay, so in clustering, we try to find patterns in your dataset without considering a label such as whether it's diabetes or not. Okay, so let's use the percentage split, and then let's try to choose EM. Now let's try to choose first the simplest, the simple k-min, and then again click start. This time it has different cluster output against your classification in our supervised machine learning video. So in here, still there's run information, your instances, your 22 attributes, Then this is the name of your clustering model, the k-means. Split 80% trained, remainder is the test, which is 20%. Okay, in here we can now, it has 11 iterations. Okay, then the more important thing here is we try to check these final cluster centroids. Okay, so our clustering model uh, was able to cluster these groups. So for cluster 0, the high BP has 0.8457. So how do we interpret this one? So we interpret it by cluster. So you derive insights from each cluster. So for example, in this machine learning model, so what can you derive from this one? So we can derive in here that patients belonging to cluster 0 have high BP, high cholesterol check, okay, with an BMI of which has a BMI higher than the cluster 1. Okay, so you compare the two groups, okay? Then they are the, okay, so from our diabetes binary, we can conclude that it seems that our cluster 0 are the patients having the diabetes binary, since it is closer to 1, and your cluster 1 has a diabetes binary value of 0.126, which is closer to 0. So which means that your cluster 0 is the group that is high risk for having diabetes binary, which is 81.61% of having risk of having diabetes mellitus, while your cluster 1 are those patients having lesser chance, or only 0.126 chance of having diabetes mellitus, since the value is 0.126. Now, you can, after knowing that diabetes binary, so you can already uh, derive insights further. So for example, in here, so under group cluster 0, you can say that those having a 81.61% of having diabetes mellitus have a higher BP, a higher cholesterol, a higher BMI, what else? A higher chance of stroke, and so on and so forth. While your cluster 1, okay, has a lower BP, lower cholesterol level, and so on and so forth. So that's how you would interpret your clustering algorithm. So as you scroll down, again, okay, it also shows you again, no? So it's the same, okay? This is the final cluster centroid. Okay, it underwent 16 again, 16 iterations, while this one is 11 iterations. So it's the same. So for your uh, clustering machine learning algorithm, which is unsupervised k-means with the iteration, this is the group. So when you do your activity, okay, that's how you compare, no? First, you 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 uh you notice your target variable. Although as I have said, in clustering, it should be unlabeled. Okay, so since it's 0.817, so maybe the cluster 0 is the group of having higher risk for diabetes mellitus. So let's try another one. Let's try the EM. Okay, so depending on the algorithm, so it may take up your resources. So let's wait a little bit. So as you can see, the status is building module on training data. Again, if WEKA seems to slow down your system, okay, you can stop anytime here and choose another cluster algorithm. Okay, so I recommend that when you do your WEKA, be sure that there is no other application running in your background so that your resources, especially your random access memory or your RAM, and your other resources such as your hard disks and your graphics card, if you have one, will only be dedicated in performing machine learning algorithms. Okay, so this is the one of the disadvantage of machine learning algorithms. You need to have a good computer specifications. So in our case, it is taking some time. Okay, so again, while we are waiting, again, you compare your clustering algorithm, okay, by group. So this group, what can you conclude in this group? For example, according to my k-means clustering algorithm, okay, the cluster 0, so you can screenshot this one, okay, and then have it analyzed, okay. So that's how you analyze. So it's taking too long. So if it's taking too long, you just click the stop button and again choose another algorithm. So we will try this hierarchical clustering, then start. Then again, if it still hangs, okay, you choose another model. But you can wait for the tasks to complete, okay. So for our demo video, okay, let's wait for a minute or maybe 2 minutes, I think. Okay. Okay, let's take another one. It's taking time. It's in the cobweb. Or let's wait. Let's stop it and use uh, using training dataset. So that's how you perform your unsupervised machine learning in WEKA. Okay. So yeah, let's wait for a minute. Okay, that's it. So it was okay now. So let us take a look what input. So for cobweb, so each algorithm is different. No, for cobweb, it was not able to separate the clustered. Okay, so let's choose another one. So it's a trial and error actually for both supervised and unsupervised machine learning algorithms. Okay, that's why when you are finished machine learning test training, testing, then you evaluate your model. Then again, you you set again another algorithms. Okay? Okay, so that's the cobweb. So let us try one more. Let's try the canopy. So different algorithms gives you different outputs. Okay? So this, for example, it's different again. So you can read the documentation. Okay? So let's stop it and then yeah, you can choose the KM. Okay, so okay, then you can split it to 70 and you try it again. So it's the same. Okay, it's a cluster. Okay, so this ends our video on unsupervised machine learning using WEKA. Thank you for listening.